I have to hit pause here. I don't know. It didn't used to do this, but just give me a second. Okay, so now, where is that? We are doing this problem right here. Do I have it right here? Let me just see if I can bring it up. Week 3 late. There we go. And then I will share screen. Sorry for the boring intro to this video. Where is it? Okay, so here's the problem. We have, so these are just some numbers. The height is going to be some number. The velocity is going to be some number. We've got this function here for this, and we're trying to get velocity at impact. Now, depending which section you had, you may have a different function, but the idea is we're trying to get V final here. So let me get this all on the screen. So Phil, what do you think? What would you do?
Oh, sorry, I was grabbing my text or my old book to grab the equations and stuff. Can I see the
Oh,
problem
right.
again?
Yeah, so we've got this velocity here. We know that this is some function of x, and I think it was, in this case, it was 3 sine
7x.
of 7x, and all the units were given. And the question is, figure out velocity at impact. What would you do first, Phil?
Oh, Jesus. What were we given?
We were given v
V
and this function and the height of the building. We also know the height of the. Everybody catch what he did first? What were we given? That's his first thought. All right, Phil, you deserve an A. All right.
Take it.
Okay, so now what? We're given v and h and this function.
Okay, we know acceleration. We know acceleration in the y.
Okay.
We know that there's no. We're assuming there's no acceleration in the x. Is there? Or do we know that?
Correct.
Okay.
We're assuming that. Very good. Notice he doesn't make that assumption until he clarifies it. Good job, Phil.
Let's see. We can probably. Let's see.
What's v initial x and v initial y?
Yeah, well, yeah, of course we have v, and then we know that v initial y would be 0.
Okay, good.
We know. Sorry, I'm just trying to reverse all of it in my head. Well, we know that we obviously know our kinematic equations. We can probably, what I was thinking, if we want to find the velocity right before impact, we can find the distance it travels to impact.
Okay.
Obviously, the height at which it'll impact will vary, because I'm assuming that's what the function is for, which means that it might impact at a different point than what we expect. But if we can find where the two will intersect, then we can determine the height and the distance that it goes in the y direction, and then we know. Then from there we can just use the normal kinematics equations to find the velocity, and then we have both velocity components because the v stays constant in the x direction, and then just use those two to just solve for a total velocity.
So just writing down what you said, v final x is equal to v initial x, sure. And we know that v final y is equal to, well, in this case, negative gt, agreed? All right. Okay, so then this is one kinematics equation. What's the y kinematics equation you would write?
Probably the change in y equals, oh, I have it here somewhere. The change in y is...
I'll help you out.
There it is, yeah. Plus, yeah, v initial t.
And what's v initial in the y direction?
And then that's 0, of course, so yeah, it just drops out.
Right? Do you
agree?
agree?
Yeah. Right.
What's delta y?
Well, it'll be, can we represent as the function?
Okay. Tell me.
Then? Well, it would be h minus...
Careful, you're on the right track.
No, wait, hold on. We're ending at...
backwards.
There, the function minus h then?
Yep.
There we go. Let's see.
Obviously, I'm being lazy with sig figs here.
No, you're good. You're good. You're good. Yeah.
Minus h.
Mm-hmm.
So now, okay, how does this help me? What do I do next? You don't have to do it, but tell me what I should do.
Oh, well, let's see. If we, as long as we have, oh, we should.
This will teach you to come to my office hours, eh?
I miss these office hours. Let's see.
I'm just gonna help.
We need to have that in terms of knowns because we're looking for. Are we looking to solve for a time? Oh yeah, well we plug it back in there. I'm trying to.
If we get time, so
yeah, we need to solve because we need to have it in terms of one known, right? Oh, I guess we have two equations, but we need one known, which means if we can solve for a time in terms of x isn't known. What is that? Oh wait, no, wait. We know the time.
I'll give you a hint. How does this equation help? We haven't used that yet.
Right, we can probably just get time in terms of x, right? And just solve for, oh, there we go. Yeah, just get time in terms of x and just plug in x.
Or so plug he's in saying he could get time equals x over v.
And then, yeah, substitute for t.
Plug that in right there.
That's what it was. Yeah,
now, how would you solve that equation, Phil?
Oh, God, we have 3 sine 7h minus h. It looks like a quadratic almost.
I'll give you a hint. This is what I was telling my class, Wolfram alpha. Or graphical methods. So this is a transcendental equation. You're not just going to solve this. So you're going to use a computer program to solve it. And that's something that I've been telling them because this is online class. So I'm like, okay, if you guys have Wolfram alpha, I'm going to up your equations can be solved now. So I don't need to be, easy. All right. So in this case, that's the right idea. Now, one could argue you could actually take this and instead just plug in for this x and instead say this is 7vt, and then you have an equation in terms of time. Agreed?
You're right. It can go either way.
Yeah.
But I think you'll end up having a nasty equation either way.
Exactly. And so at that point, what do you do?
So, sorry, go ahead. Go ahead. Sorry.
Yeah, so you're good to go. So then we go over here to Wolfram alpha. Whoops, let me clear out these zoom. Clear all drawings. So we go up here. Do I have Wolfram alpha? Okay, somewhere here. Okay, so there we go. So then what you could do is you could say solve, and then you type in your equation, which was the height. Let's just say h was equal to 5. So obviously everybody had a different height. So I think it was something like 3 times sine of 7, let's see, times, let's say the velocity was 4 times the time minus the height, which was... the height was 5, let's say, just making up numbers because you guys had numbers for these heights, was equal to negative 4.9 t squared, right?
Yeah.
And let's see if it recognizes this. I might have to say solve for t. I don't know if it makes me do that or not, but let's just see. So when you punch that in, you get some big ugly equation like that. We give it a few minutes.
What does it?
And then, oh, whoops. Let's delete that. Let's just see if it recognizes this better. And then, okay, so we could see, does it give us, there we go. So this gives us some ideas of where this thing interacts. And we're going to take this first one right here, which is the smallest one. Let's see. Something's a little bit funky here. I may have had a minus sign in here or something, but it looks like I'm just going to go like this. Maybe it's not knowing. We'll change these to the letter X, even though this should be a time, but something like that. And that gets you the time. From there, you could do the velocity pretty straightforward. All right. I've got to look at this. It's giving me some negative values here. So I'd have to, yeah, maybe I need more solutions. Oh, there's the positive ones. There we go. So I just didn't click the right button. So there's the first positive solution for this set of numbers. And so that would be where it makes impact. So if you look down here, We're assuming it's going to impact right there. So that's where we get this solution, and that would be what this looks like, and we're good to go. And again, whoops, once you get the time, you plug that into the velocity y equation. I'm going to